In our this dairy and food process and products technology course, now we shall move to what are the different preservation techniques normally followed in both liquid and solid food. In the earlier classes, we have also said that this food is such a vast course, its width and depth are so high that just not possible to cover everything in one class or in one subject. However, we also said that we will as and when we will come up with new and new terms or new and new concepts or ideas, that time we will try to explain as much possible and then proceed accordingly, right. So, that is why when we are saying this, we will be coming to this preservation techniques, right. What are the preservation techniques which are applied? This is by application of heat, by removal of cold, application of heat, and of course, we cannot say removal of, it can also be said removal of heat, but generally we are applying cold, right. So, removal of heat or by dehydration or by physical methods other than thermal, biological methods including some controls, then fermentation, then chemical preservation, irradiation and emerging technologies. So, this is encompassing the big umbrella of what are the different techniques by which you can preserve your food material for a longer period. Obviously, the processes involved in it will be not identical or similar, it will be also quite different a lot, right. Now, when we are talking about application of heat, this we are definitely associated with our everyday life. So, whenever nowadays I am not going back to very primitive old ages, whenever we are applying heat, particularly when we are making food products at home. So, what do? We apply in almost 90 to 95% cases we apply heat, right, and thereby we cook or fry or boil or simply heat for some reasons, right, and these all we do prior to consumption of the food material, right. So, application of heat we come across every almost now and then at our household processing or household whenever you are dealing with food. So, prior to consumption, if these heat are applied, then that is for cooking at home, but for commercial processes there are some more things which are associated, like what we call blanching, pasteurization, sterilization or dehydration. All these processes are commercial process, right. So, these processes we will come across and we will try to explain and understand what they are, right. So, if we see in that, the first thing which commercially we use is blanching. So, blanching is done between 75 to 95 degrees centigrade for a time period of 1 to 10 minutes. So, between 1 to 10 minutes we heat the product, again depending on the type of product, depending on the size of product, all will also where from it has come, what is the initial condition of the of the microbial population. All these will dictate what is the time, and keep in mind there is no absolute term or absolute word that only temperature or only time. It is always a time and temperature combination. It is always a time as well temperature, right. So, if it is time only specified, it will not be encompassing the situation, or if it is only temperature specified, it will also not tell the condition. It is both time and temperature together, that will indicate that what you are doing, what is the benefit or what is the loss, all aspects will come accordingly. So, generally this is the general term. The generally blanching is done by heating around 75 to 90 degrees centigrade for around 1 to or 95 degrees centigrade for around 1 to 10 minutes. That again depends on. Now, where we use blanching? Generally, we use blanching prior to drying, canning, freezing, or to delay reaching the enzyme in a, or to delay the enzyme activities so that enzymes can be kept aside. So, all these will be using blanching, but keep in mind, since processes like drying or canning, you are doing heating. Drying is done by heating, canning is also by the heating at high temperature or depending on again process, product, all together. But there you are giving heat in general, but look at the other, that is the freezing. There you are lowering down the temperature, there is no application of heat in the freezing. So, prior to freezing, if blanching is done, then that is more advantageous in that compared to the other two. In other two already, of course, I am not saying that they are not required for drying or canning, they are obviously required, but more requirement is more in case of freezing than that for the drying or canning or similar kind of heat when you are applying. So, freezing should be always associated with blanching, right. Now, why should we blanch? That thing comes into mind, that yes, we are saying that in drying when we are heating as such, or in canning when we are heating as such, then why should we undergo this blanching process? We have said that blanching is nothing but when you are subjecting the product to be blanched. This product is, the process is called blanching, and the product which we receive is called blanched product, right. So, there when you are blanching, it is temperature 70 to 95 degree and for a time period of 1 to 10 minutes. Again, I am repeating that this is depending on product, from where you are taking, size, shape, initial initial condition of the product, whether you have a lot of microbes available in that, source from where it is coming. So, all these will dictate what should be the time and temperature combination, right. So, what it does? It does the or restricts the undesirable changes in terms of odor, flavor, color, texture, and also nutritive value during storage, and this is mainly associated with the freezing term. It removes intracellular gases, minimizes potential for oxidative, it minimizes potential for oxidative changes, and so it minimizes oxidative changes, reduces microbial load, or leaches out if there be any toxic constituents such as nitrates. So, this is a compound which is very detrimental, that methamoglobinemia. So, this is very toxic in the stage of infant, where supply of oxygen to the tissues are getting affected, right. And it also removes pesticides if they are associated, right. So, by blanching we are protecting flavor, color, odor and nutritive value, and also we are escaping, we are removing some dissolved gases, some toxic materials, and also maybe some pesticides. So, all these will be associated with the term blanching, right. So, why then we use? We use to increase the stability of chlorophyll. Sodium carbonate and calcium oxide also can be added during 3-minute blanching at 90 degrees centigrade. In many cases, chlorophyll what? The color of chlorophyll is green. So, those for green material, green food material, if the original is green, obviously you would like to have more green or close to the greenness as it is available in the normal or natural food. So, while processing or while making some products, if your green color is maintained, then obviously the attraction or the commercial application will be more beneficial. So, this will help you to minimum to keep the green color of the material, right. And then in that sodium carbonate or calcium oxide all may be added as a supplement, so that the color retention is very easy, right. So, then we do it for to prevent the discoloration, we add sodium pyrophosphate, right, and this is mainly done for the case of potato, cauliflower, those who are susceptible for the temperature also. Subsequently, we will come to something, or since it has come, let me also tell here that you have seen that potato at home, when it is cut, it gets brown, right, like apple, it gets brown. When the moment it is cut and you are not taking care of that, it starts getting brown, right. There is a reason for that, we may come subsequently, because since it has come here, let me tell that this browning is known as enzymatic browning, right. The enzymes present in potato or apple, they convert this color to brown, and unnecessarily those colors which are not acceptable by the consumer is coming in. So, you do not want that. To prevent that, this blanching helps you a lot, that this enzyme can be inactivated, and to do that you are also adding some chemicals like sodium pyrophosphate that can be also added, so that the color is not getting brown. So, how then we can achieve the purpose? We have said that why should we? Now, next come why, how should we? Now, we came to first what shall we, then we came to know why should we, and now how should we perform this blanching process, right. So, method is to achieve this normally either hot water or steam or microwave, these can be used, or maybe some electrical conductions that can be used, right. So, majority in cases in commercial scale, it is steam, because that is more easy and economy also compared to any other mode of heating. But again, as in the some previous classes we said, the same shot cannot be given to everybody, because it also depends on your size, your shape, your appearance, everything. Here also some factors will come that will dictate whether that same thing can be used, that whether steam can be used everywhere, or water can be used some places, or maybe microwave, or maybe some other methods, right. Maybe heat conduction, in many cases it is also being used, but in majority it is the milk, it is the steam which is being used for blanching or heating, right. And every dark there is also a bright, or every light there is a dark. So, any good thing also is associated with bad. So, if we only talk about good, then you do not know what is the bad part of it. So, bad part of it is the blanching disadvantage, that we can call the disadvantages of blanching, is that since again it is a time and temperature, this you can appreciate afterwards when we come to another parameter called temperature quotient. We will define, perhaps we had given some introduction, but we will come more in detail there, and that temperature quotient will tell you or make you more understand that why there will be disadvantages. Since we are heating it 75 to 95, 70 to 95 degrees centigrade. So, within this range of temperature to a time of around 1 to 10 minutes. So, depending on this time temperature combination, there may be some losses of the nutrients, some discoloration or extra coloration or color fading, all these problems may be associated. So, generally around 30 to 40% vitamins and around 20% protein are destroyed. So, this loss we go that generally we lose around 30 to 40%, this is not minus, 30 to 40% vitamins and minerals we lose, and around 20% protein we lose. So, 20% generally at the most, a good source of protein, food containing protein will have at the most around 15-20% protein. So, out of that 20%, 1/5 is, if it is lost, that is definitely a good loss, right. So, this is some of the disadvantages which are associated with blanching. This is commonly also measured by the nutrient content, say the change in ascorbic acid. This is a parameter by which we can tell that change in ascorbic acid will dictate how good or how bad the blanching was, how much we lost the nutrient that can be, right. So, we have removed this. and let us go to the next page. So, this then we have come some of the disadvantages. Obviously, by case to case, advantage or disadvantage will vary, and if when you are considering one typical case, then you can more in detail, not this is in general, more in detail this can you can find out, or you can establish that whether advantageous or disadvantageous. Obviously, you will not go where everything is or advantage is less, disadvantage is more. Obviously, you will go for where advantages are very high compared to that of the disadvantage. Otherwise, without doing that would have been good enough. So, why should unnecessarily you incorporate some more things which will destroy or deteriorate the quality or the product product acceptability, right. So, in that case disadvantage is there, we have come across, and now how to measure whether it is good or bad or it has been achieved. There is advantage, disadvantage, we have already said, but how to measure that whether we have achieved our, suppose we have, for a typical case we have seen that this, if we do blanching, it will be good for the product, right. Now, whether the blanching was accomplished or not, how to know? Obviously, that will depend on, that is measured by the term called efficiency, right. This efficiency is measured with the help of two parameters called peroxidase activity, right. So, peroxidase activity is one measure by which we can say whether our blanching was sufficient or not, whether you have correctly performed blanching and achievement was made or not, that can be measured by determining the peroxidase activity, right. Now, in blanching, if that peroxidase activity is 1, some other, this is a blanching where time temperature combination we have given and said, but another application of heat can be for pasteurization. Now, nowadays whatever milk we get commercially, right, nowadays those milkman business is reduced drastically, and mostly we get it from some cooperative systems like maybe Amul, or maybe from this milk what we get from mother dairy, right. So, this kind of cooperative units, they are making the unit very successful, collecting from different parts. So, milkman business has gone down drastically. So, there pasteurization is used. Now, this word perhaps the other day I also said that this word pasteurization has come up from the renowned scientist Louis Pasteur. From there this has been established, this has been implemented commercially to destroy the pathogenic organism present in milk. So, in that pasteurization there are many ways of doing pasteurization, like either hot water or steam or dry heat or electrical currents, all can be used, and this can be coupled with the cooling promptly, right. So, by definition we can call low temperature long time, that is at lower temperature. I said that we will come to another parameter called temperature quotient after some time, maybe some class. So, there in detail, there you will see that the higher the temperature, higher is the rates of reaction. So, to minimize that, here LT that is low temperature long time pasteurization is used, and this low temperature long time and temperature combination used is 63 degree centigrade for 30 minutes, right, 60 degree centigrade, 63 degree centigrade for 30 minutes. Another that is called high temperature long time or HTST. This HTST is 72 degree centigrade for 15 seconds, right, and all are cooled to 10 degree centigrade immediately. So, we have two types of pasteurization, one LTLT, that is low temperature long time, and another HTST or high temperature short time. But keep in mind this time temperature combination is there, that is whether you are heating at 63 degree centigrade, time is 30 minutes, whereas 72 degree centigrade, time is only 15 seconds, right. There is some other that is called ultra high temperature. So, I think we have shifted. Okay. So, in at least one instant, blanching prior to canning is used to activate an enzyme. With some green beans, the epidermis is loosened upon heating and there results in a quality defect known as slugging, right. So, a moderate heat treatment which is less than 61 degree centigrade followed by a holding period prior to thermal processing, this can prevent slugging through heat inactivation of an enzyme, and this helps pectin methyl esterase which demethylates the pectin molecule, allowing cross linking with calcium ions, and this cross linking bonds the outer layer of the tissue underlying structure, preventing the slugging. So, normally earlier we had said that blanching inactivates enzymes, right, and we also gave some example like cut piece of potato or cut piece of apple when we are doing that. So, there blanching helps, that inactivation of this is possible, but in some cases activation is also done. For example, this where slugging is appearing and the tissues are being preserved by the structural tissues are preserved, so that slugging is not there, right. So, this helps a lot when we are. So, accordingly, so as and when you require, blanching may be helpful in destroying enzymes, blanching may be helpful in retaining the enzyme, right. So, again the time and temperature combination, that this is in a typical case where we are doing for the betterment of the product to be, right. So, if you look at the other thing, that these two enzymes act, this peroxidase and catalase, this can be used to evaluate the effectiveness of blanching treatment. If both are inactivated, then it can be assumed that the other significant enzymes also are inactivated. Right? The heating time necessary to destroy catalase or peroxidase, that depends on the type and size of the fruit material, fruit or vegetables or food, method of heating and the temperature of the heating medium. Although blanching of vegetables is often done in hot water or steam. So, blanching of fruit is often done in calcium brine. There calcium helps in forming the fruit, right, through the formation of some say pectates rather, through the formation of some pectates. These are formed, that calcium forms the material, right. In that case it helps it. Okay. So, this here is stop for this class because our time is over. So, next class we will proceed further.